Welcome back to our Math 171 video series. Here in this video, we'll talk about graphs and their domains. The first type of graph we'll cover is called a constant graph. A constant graph is any graph that starts from a function that says that y equals some number. If you look on the left side, our function here is that y equals 3. We can see also on the graph that we have a red line pointed horizontally, and it's at y equals 3. Anytime you have a constant graph, you will always have a horizontal line. That horizontal line will always cross through the y-axis at a position corresponding to whatever the number is. So on this graph on the left, the red line crosses through the y-axis at 3 and stays perfectly horizontal. Our questions that we've written below the graph say domain, range, and f at 2. We'll start by talking about domain here. When a question asks you for the domain, it's asking you for the possible x values. To examine the x values, we check the graph and see if there's any interruptions in the graph anywhere. We can see on this graph we have an unbroken straight horizontal line. If we look to the left side of the graph, we can see this left arrow. If you see a left arrow, that means this line will continue uninterrupted toward larger and larger negative numbers on the x-axis. These numbers will eventually go toward negative infinity, because you'll be getting infinitely larger numbers and the numbers will all be negative. So this means that the left arrow represents negative infinity. You can see that we also have a right arrow on the right side of the graph. If we follow the right arrow further and further to the right, the numbers on the x-axis would get progressively larger. They would become larger and larger positive numbers until we reach positive infinity. This means this right arrow represents positive infinity. Therefore, we will say that our domain here starts from negative infinity on the left and continues on to positive infinity on the right. To represent this, we'll say for our domain, negative infinity, comma, positive infinity in parentheses. The negative infinity is the left arrow, and the positive infinity is the right arrow. Now, if we are asked about range, those are the possible y values. We can see here that our only possible y value is the number 3, because no matter what x is, y must always be 3 for this function. Therefore, to write the range here, we'll put the range in curly braces, which will look like this symbol I'm drawing now. And we'll put a 3 inside. These curly braces will denote that there is only a single possible value for y. For most functions, we'll have a lot more than a single value, and most of the time our range won't be written this way, except for constant functions. The third question that says f at 2, that f with the 2 in parentheses, means we're going to let x become 2 and then at that position read y off of the graph. Let's indicate that on the picture. At this position I'm circling, that is where x equals 2. Let's draw a dotted line up and see what the y value is when x equals 2. I'm going to place another filled-in red dot at that position on the graph. But we can see that the only possible y value is 3. So at that position I've placed the red dot in, y is 3, and so what we'll say is f at 2 is 3. If we do the same thing with this graph on the right side that says y equals negative 2, we'll look to the domain first. Now, we can see the domain for this other constant function also has the left arrow and the right arrow. For any constant function, this will be the case. Based on the fact that this is a constant function and has y equal to some number, this time -2, we can say that the domain is still -infinity to infinity. However, the range has changed because now we have a different y value. As I've circled above, we have y equals -2, so our only possible range will be just -2 as a single value. We'll place that inside of the curly braces. Now for f at 2, let's circle the position 2 on the graph. That's the x value. We're going to let x become 2 and read the y value at that position. We'll place a dotted line going down here toward our function. And we're going to place a red dot where that intersects the function. This intersects the function here at the red dot, and the y we can see, if we read off the graph, is -2. Once again, we really wouldn't have to look at the picture as long as we just look at the function, and the function says that y is -2.